Students, welcome to science class. Let's discuss unit number 11, sound, from page number 137 to 140. First of all, we will see what is sound. Sound is a kind of energy. When an object vibrates, it makes the air around it vibrate. The vibrations travel in the air as sound waves. The sound waves carry sound energy from one place to another. A regular backwards and forwards movement is called oscillation. The time taken for one complete oscillation is called the period. The number of oscillations that are completed in 1 second is called the frequency of oscillation. A simple pendulum can be made by hanging bob on a length of string. When the bob is pulled and released, it begins to oscillate. The distance that bob travels from the central position to extreme position is called amplitude. In this diagram, you can see that a bob is hanged to a string of length L. When the bob is pulled and then released, it travels a distance. This maximum distance that bob travels from the central position to extreme position is called amplitude. Oscillations can be used to make waves. Students, next is the example of spring. If you fix a spring at one end and keep moving the other end backwards and forwards, you will see waves traveling along the spring. Waves produced by these backwards and forwards movements are called longitudinal waves. Students, you can see that in this diagram, a person is holding the spring in one hand and the other end of the spring is fixed. When the person gives jerks to the spring in forwards and backward direction, the waves are produced in the spring. The waves are called longitudinal waves because in this case, compressions and rarefactions are produced. The regions or the parts of spring where the particles of the spring are closer to each other, these are called compressions, and the regions or the parts of spring where the particles of the spring are far away from each other, these regions are called rarefactions, and the waves produced in the spring are called longitudinal waves. Remember and understand, sounds can be dangerous or irritating. Regular to and fro movements are called oscillation. The number of oscillations completed in 1 second is called frequency of oscillation. The extreme position of the bob from the central position is called amplitude. Oscillations can be used to make waves. Next, how is sound produced? When a body vibrates, it moves to and fro. Its forward movement presses the air in front of it. The particles of air move closer. This is called a compression. When the body moves backward, the pressed layer of air stretches. The particles of air move farther away. This state is called rarefaction. Continuous compressions and rarefactions produced by oscillations make sound waves. Sound waves are longitudinal waves. Waves that travel in the same direction as the oscillations are called longitudinal waves. When the loudspeaker cone vibrates, it moves in and out very fast. The compressions and rarefactions travel through the air as waves. When these waves reach your ears, they make your eardrums vibrate and you hear a sound. This is the diagram. In this diagram, you can see that there is a source of sound and sound moves through the air and you hear this sound by your ears. These are the compressions and rarefactions. The regions that are closer, these regions are called compressions, and the regions that are far away from each other, they are called rarefaction. Remember and understand. Waves that travel in the same direction as the oscillations are called longitudinal waves. Waves that travel perpendicular to the direction of oscillations are called transverse waves. Vibrations cause sound waves to travel through air. When a body vibrates, it compresses and stretches the layer of air around it. Sound waves are longitudinal waves. When sound waves reach your ears, they make the eardrum vibrate and you hear sound. Speed of sound. Sound travels in air at a speed of about 300 meters per second. This speed is much slower than the speed of light. Sound waves travel faster through hot air than through cold air. Speed of sound is not affected by air pressure. It does not change when air pressure rises or falls. Speed of sound formula. Speed is equal to distance divided by time. Sound needs a medium to travel. Sound waves are mechanical waves. They transfer sound by the vibration of particles of a material medium. Sound needs a medium to travel. Sound travels fastest in solids because in solid all particles are tightly packed together. As one particle gains energy, it is easier to transfer its energy to the neighboring particles. In liquids, sound travels more slowly than in solids because particles of liquid are not tightly packed and are farther apart from each other. Therefore, energy is gained by one particle. It takes time to transfer it to the neighboring particles. Sound travels more slowly in gases because particles of gases are very far apart from each other. They move at high speed and in all directions. This is the diagram. You can see in this diagram the particles in solid are tightly packed. That's why it is easier to transfer energy in solids. So that's why sound travels more faster in solid. But in liquid, particles of medium are not tightly packed and it takes time to transfer energy. That's why sound travels slowly in liquid as compared to solids. But in gases, there is a large gap or large distance between the particles and it is very difficult or it takes time to transfer energy. That's why sound travels slowly in gases. This is your homework. Do reading of book from page number 137 to 140. Remember and understand page number 137 and 139. Thank you.